Okay, welcome to part 2 of chemistry. We're going to be talking about naming chemical compounds. We're going to talk about naming ionic compounds. So for ionic compounds, it's not too difficult. The name is going to include both elements in the compound with the name of the metallic element first. So the metal always comes first. Okay, so metal first. Okay, metal first. Okay, metal first. If the metal has more than one charge, the charge used, you have to indicate what that charge is using Roman numerals within a set of brackets after the name of the metal. So this is very typical for iron. Okay, iron is a great example when this happens, Fe, because if you look on the periodic table, it can be a 2+ charge or it can be a 3+ charge. Okay, so this happens typically with iron. There are other elements there. All you need to do is just look at the periodic table and it will tell you all the charges. Okay, and that will be in your PAT. They'll give you a periodic table. So what follows after the metallic is the non-metallic element, a second. The only thing is that its ending is changed to IDE. Okay, so if you're working with chlorine, for example, okay, you would take out the INE and you would drop that and you would add this, okay, the IDE. So, for example, okay, and I went over this example in class, okay, if I have calcium, okay, and chlorine together. Now, if I look at my periodic table, I can identify calcium as a metal, I identify chlorine as a non-metal. So what do? Number one, first name is always the metal. So I'm going to write down, or try to write down, calcium, okay? So that's calcium. And then for my second element, okay, I notice that it is a non-metal, so I don't have to worry about, because I know it's a metal and a non-metal, I know it's ionic, so I don't have to worry about this, and I don't have to worry about, what I mean by this is this number 2. I don't have to worry about prefixes, you know, mono, di, tri, etc. I just write down the element name, and I stop right there, and I remember, okay, I gotta drop the INE, and I have to add IDE, and I'm done. Calcium chloride, okay? The important thing to remember is that no prefixes are used in nomenclature, as I just said, for ionic compounds, okay? Now, if I have, let's say I have something else now. Let's say I have this compound. Okay, now, first of all, I have to determine if it's ionic. I definitely have a metal in iron, and I have a non-metal in oxygen. That is an ionic compound. Okay, so now what I got to do, I have to go to my periodic table, and I have to determine the possible charges on iron. Okay, the possible charges are 2+ and 3+. So I have to choose between one of those two charges, 2+ or 3+. So what I need to do is I need to see how the charge is balanced in this compound, in this molecule. So if I look at the periodic table, honestly, you should just memorize the charge on oxygen as being 2-. Okay, just memorize it. Don't forget it, because it's, you know, you're going to use it all the time. You're going to see it all the time in chemistry when you go into high school, for sure. Okay, so I noticed this. When I look at the original formula of my compound, it's in a 1-to-1 ratio. That means that my charges on iron and oxygen have to balance out exactly. So it would make absolutely no sense to me, and it makes no sense that if we would work with this charge. So it is not 3+, because the charges have to balance out. Therefore, I know that the charge on my iron is going to be 2+. So now what I'm going to do is I'm going to go ahead and name it. So metallic goes first. Iron, and I have to communicate the charge because there are more than one possible charges. Okay, iron 2, because it's a 2 plus. We deduce that by looking at the charge of the oxygen. Iron 2 oxide. And that's naming it. Okay, so now for writing the chemical compounds, chemical formulas for ionic compounds, you got to print the metal element symbol with its ion charge, and next to it print the non-metal elements with its ion charge as well. And the important thing here, and the tricky part, is you got to balance out the ion charges. So the positive ion charges must balance the negative ion charges, so they got to be the same. So then you write the formula by indicating how many atoms of each element are in it. You don't need to include the ion charge in the formula. That's just there for you to do bookkeeping, to balance out the charge. You place the number of atoms of each element in a subscript after the element symbol. If there's only one atom, only the symbol is used. You don't have to put the number 1 down. Okay, so let's do an example. Okay, let's just do the one we already did here, okay? So if I need to do, let's say I want to write down calcium chloride, okay? So what I do for calcium chloride, I go ahead and I write the symbol. If I don't remember, I look at the periodic table, and it has a 2 plus charge. Okay. My chlorine, I look at the periodic table, it has a -1 charge, right? So what I do is I do what's called the drop and swap method. Okay, so I drop it and I swap it. Okay, if I have 2 calciums here, 2 plus calcium, right? I'm gonna need 2 chlorines to balance out the +2, because each chlorine is -1. That's why it charges out, it balances out that way. So all I need to do is just drop and swap it. Okay, so if I drop and swap it, all I need to do is I go ahead, I take the number 2, I drop and swap. Okay, I take my number 1, I drop and swap. Okay, I don't touch the charges here, so I just go calcium. Okay, I have 1, so I don't write anything there, and I do the chlorine. I took the 2, dropped it down, so that's my formula for calcium chloride. Okay. Okay, so naming molecular compounds and writing molecular compounds. Just a little bit different rules for writing molecular compounds. Just write the entire name of the first element. Okay, so if it's carbon, if it's nitrogen, just write that first name. If only one atom of the first element is used, you don't need a prefix. If more than one is present, a prefix has to be used. Okay, but for the second element, you follow the same rule for ionic. Change the ending to IDE. But for molecular, the difference is that you're always going to use a prefix for the second element. It doesn't matter even if you have only one element, you would use the prefix mono. For example, carbon monoxide, right? So carbon monoxide, your second element here, there's only one, but you would use the prefix of mono. So your prefixes are mono 1, di 2, tri 3. 4 is tetra, penta is 5, hexa 6, hepta 7, octa 8, nona 9, deca 10. Let's do an example. So if we have this compound or this molecule, okay, we would go ahead and we would see if we can identify it as being molecular or ionic. In this case, we have carbon, which is to the right of the staircase on the periodic table, therefore it is it's not a metal. Chlorine is also to the right of the staircase, so it is a non-metal as well. 2 non-metals, it's a molecular compound, so let's follow those rules. First one. The first rule is we take our first element and we write it out completely. So we got carbon. And notice that I'm not capitalizing it. Okay, carbon. There's only one, but because it is the first element, we do not use a prefix. We don't use a prefix. Now we look at our second element. We notice there's a 4. So we have to write the appropriate prefix. In this case, it would be tetra. And then we have the name chlorine, but we stop there, drop the INE and add IDE. Carbon tetrachloride. Okay, another example, say you're given this, N2S5. Okay, first thing you do, you write down the first element. Okay, nitrogen. Okay, nitrogen. Okay, and then you go, whoops, oh, I made a mistake. Okay, mistake is simple. Look at that. We've got more than one, so we have to attach a prefix. In this case, we look at our prefixes. We notice that 2 is di. Okay, so that's dinitrogen, and we have S is sulfur. Okay, so we have 5 penta. Okay, now in this case we don't have to drop an IDE because, or an INE, because sulfur doesn't have it to begin with. So what we have to do, we have to add the IDE. Drop the UR, add the IDE. And that's how you name molecular compounds. Okay. To write the molecular compounds, the formula of the molecular compounds, so working the other way around, what you got to do is you write the symbols for the elements in the same order as they appear in the name. Okay, so carbon tetrachloride, carbon is first, chloride is second, and all you do is just work backwards and translate the English, the prefixes, to math. So give them numbers. So tetra is 4, you have 4 chlorides, so that means, so 4 chlorine, sorry, and then you just put a 4 there. Okay, so let's see if we can do an example together. Okay, so let's say I have this name, so I'll try writing out, bear with me, tricarbon octafluoride. So what I have to do is I just have to write out the element symbols in the order that I see them. Alright? Oops, that's an E. That just looks funny. Okay, so I have to write out what I see. I see carbon. I've got tri, so tri means I have 3 of them. So I have to put a 3 there. Fluoride, right? I got to attach the, I have to recognize that, you know, that should be an INE when I'm talking about the actual elements. So then I go carbon, and that's like my carbon, that's my fluorine, and octa means 8, so that means I have 8 fluorines. There's my molecular formula. Okay, chemical reactions. Very important to know. The chemical reactions happen when 2 or more substances combine to form 2 or more new substances. The reactants are substances that are going through the reaction and are combined in the reaction, and the products is what you get. So if I have a chemical equation, just like, you know, this plus something is going to give me my, that's supposed to be an arrow, it's going to give me my products. Okay, this side here, okay, on this side, those are reactants. On this side, those are my products. Okay. There are different kinds of chemical reactions. There's oxidation, which is a chemical reaction in the presence of oxygen. So that's like rusting of iron. Corrosion, iron combines with oxygen to produce iron oxide, or iron 3 oxide, I should be clear on that. Combustion is a very exothermic reaction that happens when things are burned, releasing a lot of heat energy. So it's a combination of a substance with oxygen that results in the production of carbon dioxide water, and heat energy. Okay, so that's the burning process of gases that are used to, let's say, heat our homes and fuel our cars. Okay, an endothermic reaction. Endothermic reactions are chemical reactions that absorb energy, and so it's taking energy away from the it's absorbing energy. Okay, so if something is absorbing energy, it's taking heat energy away from its surroundings. So a really good example of that is a cold pack. When you snap a cold pack and you have the reactants combined, it starts to feel cold, and that's because it's drawing heat energy away from its surroundings. So it's drawing heat energy away from your knee, your elbow, your head, whatever's injured, and that's why it feels cold. Exothermic we talked about. You're going to learn a little bit more about the types of chemical reactions in grade 10. Formation, composition, decomposition reactions, single replacement, double replacement reactions. You'll learn all about that in grade 10. So I won't talk about them here. But what I will talk about is the conditions that affect the rates of reaction. So how are things going to either, in terms of chemical reactions, how can you speed them up, how can you slow them down? Well, one way is heat. The greater the temperature, the faster the chemical reaction will go. The lower the temperature, the lower the chemical reaction will grow. That's the whole principle why refrigeration keeps your food preserved, because it's a chemical reaction when food goes bad, and decreasing the temperature slows that chemical reaction dramatically. Concentration. The greater the concentration of the substances, the faster the reaction. The lower the concentration, the slower the reaction. Surface area. Increasing the surface area of the reactants will increase the rate of reaction. So if I take Alka-Seltzer and I put it in water, it'll fizz. But if I break up that Alka-Seltzer tablet in water, I increase the surface area. I increase the amount of water that is exposed to the Alka-Seltzer tablet, and thereby I'll get a faster reaction, I'll get more bubbling. Catalyst. A catalyst is a substance that helps increase the reaction rate by lowering what's called an activation energy. Okay, the energy needed to make the reaction occur. So all you need to know about catalysts is catalysts help the reaction go. Okay, so for example, enzymes are catalysts. They help speed up food digestion. The example I gave in class was a catalyst is like a setup. Okay, so let's say you're at the junior high dance and your friend thinks that you would really get along well with this other person, and so that person can act as a catalyst to get some sort of to get you guys to dance. So he or she will go to the person and say, hey, what do you think of this person? Would you like to dance with that person? And that person will say, yeah, it sounds really cool. I think that person is really neat. And then that catalyst will go back to the first person and say, hey, you know what? This person is interested and wants to dance with you. And then next thing you know, you guys end up dancing. Okay, so that's a catalyst. A catalyst is a substance that will help a chemical reaction to occur. Okay? So the more catalysts, if in the presence of a catalyst we can get a chemical reaction, in the absence we might not get a chemical reaction at all, or a very slow reaction. Okay, the law of conservation of mass is something we talked about. It's a thermodynamic law. Basically, things do not just pop out of anywhere. Things do not just get destroyed. You cannot create or destroy matter. Matter is just converted from one form to another. Therefore, the mass is always conserved. So in a chemical reaction, if I have substance A reacting with substance B, and I get a simple formation reaction, I get AB. Okay, if I have 10 grams of A and 10 grams of B, the law of conservation of mass would indicate that I will get 20 grams of AB. Okay. Okay, drawing compounds. Drawing compounds is something you won't have to do on the PAT. They're not going to ask you to draw anything. But I can see them asking, giving you, let's say, a molecular formula and having you to pick which one would be more accurate. So you need to know how to draw them. The following diagrams that I have here are going to explain how you can do that. So the first thing you got to do is you got to use a formula to tell you the type and the number of atoms. Okay? So the periodic table will tell you the relative sizes of the atoms. Okay? All you need to do is just look at the atomic number. The smaller the atomic number, the smaller the atom. Okay? And then, so you have to take that into account when you're drawing it. So, and all you need to do is just balance the atoms when drawing the molecule. So we got a couple of examples here. So sodium chloride. If I look at the periodic table, sodium chloride, sodium, I remember its atomic mass is, I think it's 22.99 or 23. Chlorine, I think it's actually, yeah, it's 35. So this is about 23, and this would be 35. Okay? So I could tell you right there that chlorine is bigger. So when I'm drawing the molecule, I have to make sure that my chlorine atoms are bigger than my sodium atoms. It's that simple. So how many of each do I have? I've got one sodium and one chlorine. So all I do is I draw a big circle here that represents my chlorine. I would label it Cl, okay, to indicate that I know that it's chlorine. And then I would label this Na to indicate that it is sodium. Okay? And that's how you draw it. That's it. Okay, so again, carbon dioxide. The molecular mass of carbon, I believe it's 12. Okay, and oxygen, I think it's about 8. Okay, so again, right there, carbon is bigger. Oh, I'm thinking I'm getting these numbers wrong here. Wait a second. Let me erase that. Sorry. So with the period, I'm not remembering the masses of oxygen and carbon dioxide right now. I'm pretty sure carbon is 12. And I think oxygen, actually yes, oxygen, you know, 8 is the atomic number, 16 has got to be the, yeah, that's correct. So you have 2 oxygens, right? So because you have 2 oxygens, you're going to have to draw 2 oxygens. They are bigger than carbon, therefore you have to draw them bigger than carbon, and that's carbon dioxide. Okay, that's the review of chemistry. I really hope that's helpful. I guess I'll make one for the next unit. Okay, good luck studying. Ask me questions if you need.